Welcome to Science in Your Shopping Cart, a new series that shows how science touches many of the products you buy at the grocery store, from new varieties of fruits and vegetables to technological advances that make your food safer, cheaper, and tastier. I'm Todd Silver. There are over 2 million farms in the United States, many still owned by small family farmers. The environmental impact of all these farms is enormous. These farms produce millions of tons of waste per year, called biomass. Some of this is recycled back into the ground or used as cover to protect crops in the winter. However, ARS scientists are also researching ways to turn biomass into environmentally friendly products. For this episode, we're not going to start in the field or orchard or even a lab, but rather we're going to start in a distribution warehouse. You see, workers here are using these wood pallets to help transport heavy materials. These pallets have to be firm, but also flexible, and they have to handle hundreds, if not thousands of pounds without being crushed. ARS researchers in Albany, California, have created pallets out of biomass, specifically discarded low-value almond and walnut shells.
Amazing material. This is a torrefied material. You blend it with traditional plastics, and torrefied means it's heated without oxygen. So instead of burning, it just chars and turns black. And then it makes it more hydrophobic, which is good for plastics. So now you can blend it with plastics and it'll kind of bind and form a nice composite. These are test samples, but this is actually...
Dr. Gregory Glenn is a plant physiologist with ARS's Bioproducts Research Lab in Albany, California. He works with research leader Dr. William Orts on developing environmentally friendly products that can replace non-biodegradable plastics. Their pallet invention is already being used by warehouses in California, with more orders coming in.
Plastics are a wonder at what you can do with them and how easy they process. That's why they're used everywhere. There's so much you can do with plastics and they're cheap.
The problem comes at the end of the plastic item's life. Some can be recycled, but many are discarded and end up in our landfills and oceans. The scientists here in Albany are creating biodegradable and recycled plastics made from discarded agricultural materials, like these pallets comprised of discarded almond shells. The key to producing bioplastics is in the machinery. Here at the lab, researchers created a torrefied heating machine that looks more like a life-size mousetrap game. There's a large yellow bucket where the raw material is dumped into, and then a rectangular heating unit, followed by steel rods attached to a compression gauge. Better yet, let me let the experts walk you through it.
Charcoal plus post-consumer recycled plastic comes together in the extruder, comes out as a tube, but then you chop it into pieces and becomes a resin. Then we give that resin to the pallet maker.
The whole idea here is you take those pellets go in here. This is like a big glue gun. It heats and it pushes it out and it comes up. This is all heated. It comes up here. You can kind of see some of the plastic right there. It comes up as a ring, and then you blow air into it, so like a balloon, and it expands. So now you've got a tube of film coming up, and it gets contracted in between these, and a roller grabs it. By this time, it's cooled off. So when you roll it, it's not going to stick together. When you start rolling it, it's just like a big piece of plastic. And this piece of equipment is really important in the plastics industry for making all of your bags into products.
ARS researchers and their partners are diverting thousands of tons of plastics from landfills to make pallets that are stronger, sturdier, and more flexible than wood pallets. So, not only do these new pallets reduce the amount of plastics in our landfills, but they provide an environmentally friendly use for low-value shells.
Adding value to agricultural products helps the rural economy, helps the farmer. Most of the things we do will lower greenhouse gas emissions. So degradable, compostable products end up helping the environment. So what we try to do when we're imagining a product is imagine the end of its life. So it has a use, and then it has an end of life that we predict that prevents it from going to landfill.
Their biolab looks like an island of misfit toys, where all these discarded agricultural materials get a second life, benefiting consumers and the environment. Here, they're developing planet-friendly drinking straws, renewable plates and cups, concrete materials made with wheat starch, and even a fiber-based replacement for styrofoam.
This insulates as well as styrofoam. We think this is going to be one of the answers to replace styrofoam in certain applications. Those markets are really opening up, and we need to have an answer for single-use containers. And still today, if you look at restaurants, the styrofoam takeout container is still used everywhere. Those are markets that we want to get into, and we think that if we can, that'll really make a difference as far as sustainable packaging, filling up our landfills, all of that will be reduced if we develop these technologies. This whole idea of single-use disposable products that can be composted, I think that's the future.
Dr. Orts and Dr. Glenn have big picture plans where end-of-life materials are no longer tossed into landfills. Rather, they are either recycled or composted. In the future, every item you place in your shopping cart will be packaged with the environment in mind. We see them everywhere we shop. Plastics. They're easy, they're convenient, and they're a serious concern for the environment. Discarded plastics and microplastics, they end up in our landfills and find their way to our oceans, posing dangers to our marine life and long-term risks to our ecosystem. I was reading an EPA blog that had a stunning thought. Much of the plastic ever made is still around today. A lot of research here at ARS focuses on food. After all, we are part of USDA. But we're also stewards of the environment, and therefore always looking for ways to protect our precious earth.
I hope we can leave the world greener, more greener than when we came in, So hopefully we can develop some products which really helps the environment.
That's Dr. Atunu Biswas, a research chemist at the Plant Polymer Research Unit in Peoria, Illinois. Dr. Biswas is developing biodegradable plastics comprised of biomass, in this case, cotton gin trash.
Our goal is to make bio-based polymers using renewable resources such as agricultural byproducts. These materials are biodegradable and sustainable. In the case of cotton gin trash, this is a byproduct nobody wants. So our approach is to blend inexpensive agro-based biodegradable material such as cotton gin trash with more expensive polymers such as polyvinyl alcohol.
Cotton gin trash is the waste material left over after cotton is processed for clothes, medical materials, and other textiles. Cotton producers still use cotton gin machines, which were invented back in the late 1700s. Farmers toss large cotton bales into the cotton gin, which looks like a huge mechanical drum with hooks, and the hooks separate the fibers from the seeds and other unwanted plant waste. The waste piles up on the farmland with very little value. Dr. Biswas is taking this cheap, abundant resource and turning it into an environmentally friendly polymer that can reduce the amount of synthetic polyvinyls used in plastics, as well as shampoos, paints, and other applications.
Polyvinyl alcohol is kind of expensive. So we thought, why not we replace some of the polyvinyl alcohol with cotton gin trash, which is very cheap.
Cost is something that's not always talked about in science, but it's vitally important. You see, it's one thing to come up with an environmentally friendly product that can replace plastic, but if the new product is too expensive to produce, that's a tough sell to the industry. The beauty of agricultural waste is that it's biodegradable, abundant, and cheap. Researchers are also finding that the simplicity of biomass makes it relatively easy to turn into polymers, oils, and other earth-friendly products.
Price is the key, and since we are using agricultural excess, you cannot get anything cheaper. It is almost creating a wealth from waste. That's our approach.
Dr. Biswas mentioned that industry members are very interested in his biodegradable polymer blends, and considering the amount of cotton gin trash available, it wouldn't be difficult to scale up to meet commercial demand.
Since World War II, the synthetic polymers have grown to dominate many of the items in our homes. Clothing, toiletries, packaging, containers, personal care, almost anything around us are polymers. So for many years, these materials after use has been dumped into landfills, which are unsightly and take up space. What can we do? Our solution is agro-based biodegradable polymer. These can benefit environment in several ways. They can be formulated to have similar properties as synthetic polymers, but they are more easily disposed of and recycled. They may lessen burden on our existing landfills and lessen the impact on environment.
Before we get to our next story, let's look at other ARS discoveries that could benefit our ecosystem. For all you Grill Kings, ARS scientists developed starter briquettes, which are comprised of porous charcoal material that can be easily lit without lighter fluid. Lighter fluid contributes to the level of volatile organic compounds in the air around residential neighborhoods. Cat litter is a multi-billion-dollar market, and that's nothing to scratch at. There are over 90 million cats living in U.S. households, and every one of them needs a place to do their business. ARS scientists developed a bio-based cat litter made from renewable, low-value plant fibers. And speaking of cats, their flying feathered friends are also helping the environment. ARS researchers are turning chicken feathers into pellets, which in turn can be made into biodegradable plastics, including flower pots. Need more fruit in your diet? ARS researchers developed the world's first all-fruit bar, containing 100% fruit with no preservatives, no fillers, and no artificial ingredients. Best of all, these bars are made from damaged, bruised, or oddly shaped fruit that would normally be discarded. Ready for a fill-up? ARS researchers are developing ways to turn unwanted, fast-growing grasses like switchgrass, big bluestem, and Indian grass into biofuels. Links to all these amazing research projects can be found on our podcast site. And for more cool ARS discoveries, check out our online magazine, Tell Us. Now back to the show. Corn is one of the most widely grown crops in the United States. Sure, you and I eat lots of popcorn. We eat frozen and canned corn, corn tortillas, and of course, that delicious sweet corn that puts us in a summertime mood. But corn is also used to produce ethanol. It's used as a sugar substitute and as feed grain for livestock. Over 13 billion bushels of corn were harvested for grain production alone in 2019, and over 480,000 acres of sweet corn were planted during that time frame. But with all that product comes millions of pounds of waste after harvesting. Some of the corn waste, which is also called corn stover, it's recycled back into the fields, but that still leaves millions of tons of biomass. A very cheap resource looking for a new lease on life.
There's a lot of agricultural waste, such as rice straw and wheat straw and corn stover, soybean stover, and sorghum stover, and even some of the byproduct like fruit peels and fruit skin, something like that. Because these stuffs are renewable and we can use it to produce some more like value-added products such as cellulose and nanocellulose.
That's Dr. James Zhu, research physical scientist with the Plant Polymer Research Unit in Peoria, Illinois. Dr. Zhu noted that even byproducts of corn, such as ethanol, produce waste that could be turned into other bioproducts.
The byproduct of the ethanol contain a lot of cellulose, hemicellulose, and lignin, and from these byproducts and produce some cellulose and nanocellulose because they are biodegradable materials. Cellulose has a lot of application in like a paper production and pharmaceutical drug delivery and even in food products.
Cellulose is the substance that is responsible for a plant's strength. If cellulose is reduced to a nanoscale, which is 1/1000th of a meter, it's called nanocellulose. Unlike cellulose, which is not soluble in water, nanocellulose can be suspended in water and formed into a hydrogel, like a super water absorber. Dr. Zhu and his team are producing biopolymers, such as nanocellulose, from corn waste as a replacement for popular synthetic plastic products, including pharmaceutical gel caps, cosmetics such as hair gel, even polymers for treating wastewater.
Right now, most of the cosmetic hair gel is synthetic polymers. These market is huge. If we can replace only part of it, that will benefit both. Environmentally, its impact is good. And then the agricultural waste, we can use it and add values.
ARS researchers are also testing plant polymer-based products, such as starch-based and cellular-based, as alternatives for the rubber used in shoes and even the outer shell of computers. These two items are primarily produced with non-biodegradable materials and too often find their way into overburdened landfills. But the potential uses don't stop there.
In the market right now, a lot of hydrogels are not really 100% biodegradable. And hydrogels can absorb huge amount of water, up to several hundred times of its own dry weight. Last year, we developed some cellulose-based hydrogels, which can be used like agriculture seeds coating. So we use these hydrogels and plant these seeds in the field. So you don't have to water the field. It can absorb water in the soil.
With a vast number of uses being explored, nanocellulose materials can significantly reduce the amount of corn waste after harvest and add environmentally biodegradable products into the marketplace. But first, researchers have to figure out how to make these products cost competitive.
The only problem right now is the price is not really comparable to the synthetic one, because the synthetic polymer is very cheap. That's the reason that the people use that. However, the environmental impact is huge. There is a huge ton of synthetic polymers dumped in this world every year, so that's a problem.
Using low-value products like corn waste after harvest, that certainly helps keep costs down. Scientists are also researching ways to simplify the process to produce the nanocellulose material with less labor and less machinery. The most important factor, though, is demonstrating the long-term benefits of producing biodegradable materials with agricultural waste.
We are doing research about the biodegradable materials. So it's difficult to see the benefit in the very near future. However, I believe our research is a long-term impact on the environment.
Thanks for listening to this renewable and biodegradable edition of Science in Your Shopping Cart. Stay tuned for future podcasts. And in case you missed it, check out our other podcasts on apples, spinach, potatoes, and tomatoes. For Science in Your Shopping Cart, I'm Todd Silver.
Science in Your Shopping Cart is produced by the Office of Communications, Agricultural Research Service, an agency of the U.S. Department of Agriculture. For more information, visit www.ars.usda.gov. Follow us on Twitter, LinkedIn, and Instagram, like us on Facebook, and watch us on YouTube.